Okay, so this is the review for the Unit 2 exam, which covers Chapter 3 and Chapter 4. So this will be the Chapter 3 portion, and in a little bit I'll do the Chapter 4. So the first couple of problems we have to do construction. So we're in number 1, we're supposed to construct a perpendicular line that passes through the point Q. Remember that perpendicular means two lines that intersect at 90 degrees. So in essence, eventually I want to draw a line that intersects line L at 90 degrees and goes through Q. So in the end, I want a line that looks like this. So start with putting your compass at Q, opening it up, open your compass up past your line, and you create an arc. What you want is you want two spots where your arc intersects the line. So mine intersects right there and there. It doesn't matter where it intersects, it just needs to intersect the line twice. So now you put your compass here at this point of intersection and draw an arc, and here at that point of intersection and draw an arc. Where your two arcs intersect, this point right here, you want to line that up with Q. And when you line that up with Q and you draw a line, that line will be perpendicular through L, perpendicular to L, but through the point Q. Number 2, we're supposed to construct a parallel line. So a parallel line goes in the same direction but never touches. So in effect, I want a line that goes through Q, and I want a line that looks like this. So to construct that, we start with any point we want on the line. So I'll pick a spot right there. I open up my compass to Q, and I make an arc that goes through Q and it goes through the line. So there's Q, and there's where my compass intersects the line. So I want to go from these two spots right now, making sure I do not open or close the compass. I need the compass open to the same amount. From Q now, I make an arc, and from this point of intersection with the line, I make an arc. You can see that my arcs intersect at this spot right here. I'm going to connect that spot with Q, and that'll give me a parallel line. So these lines are parallel. In number 3, I'm supposed to construct a perpendicular bisector. Again, perpendicular means to intersect at 90 degrees. Bisector means to cut in half. So I need to cut this line in half, line segment, in half, at 90 degrees. So I'm looking for a line somewhere here, but exactly down the middle. So start with your compass at Y. Open it up so you know that it's more than halfway across the line segment, and make an arc. Flip it around, keep your compass open to the same amount, put your compass on X, and make an arc. You should get 2 points of intersection, one above and one below. You need those 2 points of intersection to connect, and when you connect that, you will create a line that's perpendicular to XY and also bisects XY, cuts it into 2 equal pieces. So number 4 involves solving for X. We need to know what type of angles these are first before we can solve. And before we need to decide what type of angles they are, we need to know what our angle choices. So our choices are corresponding angles. Corresponding angles are angles that are in the same spot when they're formed by 2 lines and a transversal. So like here and here would be corresponding because they're both in the top left. Same side interior is another option. Same side interior means they are on the same side of the transversal, so either to the left or to the right of the transversal. Interior means between the 2 lines, the 2 parallel lines in this case. So these are in fact same side interior angles. Corresponding angles, if lines are parallel, we should know that they are congruent. Same side interior angles, if your lines are parallel, we need to know they are supplementary. The other options are alternate interior, angles. That means they're on opposite sides of the transversal. One's on the left, one's on the right, but still in between the two parallel lines. Then alternate exterior. Again, that means they're on opposite sides of the transversal. That means left and right of the transversal, but outside the two parallel lines. So here and here would be alternate exterior. All of these are congruent to each other when lines are parallel. So we decided it was same side interior because they're on both the same side of the transversal. They're on the right and in between the two parallel lines. So when lines are parallel, same side interior angles are supplementary, which means that 7x plus 24 and 72 add up to equal 180. So when I add 24 to 72, because those are like terms, I get 96. If I subtract 96 from both sides, I get 7x equals 84. And if I divide by 7, I get x is equal to 12. So in number 5, I need to solve for x to make these lines parallel. Well, these angles are alternate interior angles because they are on opposite sides of the transversal, but in between these two lines. If these lines are going to be parallel, these alternate interior angles should be equal. So 3x should equal 2x plus 20. So if I solve this, subtract 2x from both sides, I get x equals 20. If I plug that back in, I get 3 times 20, which is 60. This is 60 degrees. And if I do 2 times 20 plus 20, that's also 60 degrees. So you can see both of these are 60. If both of these are 60, that means that these alternate interior angles are equal. And if alternate interior angles are equal, that means those lines should be parallel. Number 6 is a little trickier because it's not any of the angles we know. These angles here that are marked are not corresponding. They are not same side interior. They're not alternate interior, and they're not alternate exterior. I'm redrawing this because I need a little bit of some space. Look how 3x is here. Okay. I could move the 3x over here because these are vertical angles. Angles that are across from each other when two lines intersect are called vertical, and those are always equal to each other, whether your lines are parallel or not. So now I form same side interior angles with 2x plus 20 and 3x. So if those are same side interior angles, they should add up to equal 180. So combine those two like terms. It's 5x plus 20. Subtract 20. And divide by 5. You get x equals 32. So if x is equal to 32, that would make this equal to 96. That would make this one equal to 84. Same side interior angles would be supplementary, making my lines parallel. Number 7, we need to complete this proof of the alternate interior angle theorem. We definitely are not allowed to use alternate interior angles because that's what we're trying to prove. So what we need to do is start from knowing the fact that L and M are parallel to each other. We have to show that angle 2 and angle 3 are equal. So my first statement should always be whatever is given to me. So I'm given that L is parallel to M. They tell me that. And the reason that I know that L is parallel to M because it is given to me. Okay. The next statement that was said is that angle 1 is equal to angle 2. That's true, and that is true because angle 1 and angle 2 are vertical angles. Vertical angles are always equal to each other. So we can say vertical angles are always equal, definition of vertical angles, whatever we want, but those are congruent because they are vertical angles. 1 and 3 are equals, the next thing they said. 1 and 3 are corresponding angles. But we can't just write corresponding angles. We can't write the definition of corresponding angles because corresponding angles are not always equal. In fact, they're only equal if your lines are parallel, and we do have parallel lines. So we have to write this statement. If lines are parallel, and L and M are parallel, then corresponding angles are equal. I'm going to write congruent. So we have to write a sentence there because corresponding angles aren't always congruent. They're only congruent if your lines are parallel. We didn't write a sentence for vertical angles because vertical angles are always congruent, no matter what. So L is parallel to M, so 1 is equal to 2. 1 is also equal to 3. So 2 is equal to 1, sorry, if 1 is equal to 2, and 1 is also equal to 3, then I know that angle 2 has to be congruent to angle 3 because of the transitive property. The transitive property says if angle 2 is equal to angle 1 and angle 1 is equal to angle 3, then angle 2 is equal to angle 3. So we show that these alternate interior angles are congruent if your lines are parallel. Number 8, we are using the alternate exterior angles for converse, meaning going backwards. If you have two alternate exterior angles being congruent, you show that the lines are parallel. Again, we are not allowed to use alternate exterior angles. We start with our given statements. Anything they tell us, okay, just assume, pretend angle 1 is equal to angle 8. So we know that already, because they gave that to us. 1 is equal to angle 2, because that's given to us. And that's not given to us, sorry. Those are vertical angles. Vertical angles are always equal. The next thing they said was angle 2 is equal to 8. Angle 2 and 8 are congruent. Those are alternate exterior angles, but we can't write that. We're not allowed to write that yet. Sorry, those are corresponding angles. But we don't know if the lines are parallel yet, so we can't say that the corresponding angles are equal. So 1 is equal to 8. 1 is also equal to 2. That means that 2 is equal to 8 by the transitive property. Since 2 or 8 are equal, and those are corresponding angles, and if I have corresponding angles equal, then I know my lines are parallel. So J is parallel to K, because if corresponding angles are equal or congruent, then my lines are parallel. In number 9, I have to write an equation of a line that goes through this point and perpendicular to this line. So in the end, I want an equation of a line that looks like in this, y equals mx plus b. That's how we normally write our equations of lines. I want it to be perpendicular to this line, so what I need to do is steal the slope off of this line, find that slope. The slope here is 5, because it's in slope-intercept form. Here's the slope. I want to be perpendicular to this line. So to be perpendicular, perpendicular slopes have to be opposite reciprocals. Opposite meaning they have different signs. This slope is positive, so the slope I want, the perpendicular slope, has to be negative. And reciprocals, this is 5 over 1. The reciprocal, that would be 1 over 5. So the slope I want is negative 1/5, because that would be a perpendicular slope to this line. Now I need to use that slope and this point to write an equation of a line. Those are the two things on my line. I know they have to have this slope and that point. So I'm going to use this point and plug it into y equals mx plus b. I'm going to plug in 2 for y. The m I just calculated was negative 1/5. The x is negative 10. And the b for the line, the new line I'm writing, I don't know. A lot of people will grab that 7 for b. That's the b for this original line that I want to be perpendicular to. It's not the b for the line I want. I have to figure out what the b is for the line I want. Negative 1/5 times negative 10 gives me positive 2. And if I subtract 2 from both sides, I get b is equal to 0. So I want to make sure I write my equation in slope-intercept form. So I'll write y equals, my slope was negative 1/5, x, and my b is 0, so plus 0, which I do not need to write. And number 10 is very similar. I have an equation of a line that goes through this point, but I want it to be parallel to this line. In the previous problem, I could just grab the slope here because this line was written in slope-intercept form. This line is not written in slope-intercept form, so I need to get it there. So I need to subtract 3x. And then I need to divide by 2 to get it in the slope-intercept form so that I can just pick out a slope. So the slope for this line is negative 3/2. And since it's parallel lines have the same slope, I want to keep that slope. I use 6(1) to plug it into y equals mx plus b. So 1 equals negative 3/2, 6 plus b. Negative 3/2 times 6 is negative 9. And if I had 9 on both sides, I get b is equal to 10. So the equation of the parallel line that I want is y equals my m of negative 3/2, x plus my b of 10. Number 11, I need to decide if these lines are parallel, perpendicular, or neither. We've already discussed that parallel lines have the same slope. Perpendicular lines have opposite reciprocals. And neither, if lines are neither, they're just intersecting, coinciding, and just whatever. It doesn't have the opposite reciprocal part. So in 11, I need to find the slope between these two lines. Line 1 has these 2 points, line 2 has those 2 points. So I need the slope formula. y2 minus y1 over x2 minus x1. So for the slope on line 1, it's 9 minus 5 over negative 8 minus 10. 9 minus 5 is 4. Negative 8 minus 10 is negative 18, which reduces to negative 2 over 9. Slope for line 2 is negative 6 minus negative 4 over 11 minus 2. So negative 6 minus negative 4 is negative 2 over 9. These have the same slope, so these are parallel. Part B, doing the same thing, find the slope of line 1, negative 1 minus negative 5, and 2 minus 3. This gives me 4 over negative 1, which reduces to negative 4. On line 2, it's 7 minus 3, 1 minus 0. It's 4 over 1, which is positive 4. These are not the same, so they're not parallel. They are opposites, but they're not reciprocal, so they're not perpendicular. This is neither. In part C, same thing. Slope of line 1, 7 minus 3, Negative 5 minus negative 9. This is 4 over 4, which is 1. 2 minus 6 over negative 7 minus negative 11. It's negative 4 over positive 4, which is negative 1. These are not the same, not parallel. These are opposite, one's positive and one's negative, and these also happen to be reciprocal. So if you take the reciprocal 1, you also get 1. So these are perpendicular. So that was chapter 3. Let's go ahead and review chapter 4 also. So in this problem, I have to graph my original triangle J, K, and L, and have to apply this glide reflection. I need to translate it with x minus 6, y minus 1, and I need to reflect that result across the y-axis. So first of all, 3, 1 is here, 4, 2 is here, and 1, 3 is there. So this is J, K, and L. So the translation, x minus 6, y minus 1, I can take these points and plug it into the rule, or what I can do instead is just know what this means. This means move to the left 6 and down 1. So I can take each point, move it to the left 6 and down 1, and I'll have my primes. So 1, 2, 3, 4, 5, 6, down 1. That's my L prime. 1, 2, 3, 4, 5, 6, down 1. J prime. K prime. 1, 2, 3, 4, 5, 6, down 1. So that's my result after the translation. Now I have to reflect it across the y-axis, which is this line right here. So I'm going to get a shape that overlaps my original one. Notice how K prime is 2 units away from this y-axis. So K double prime is 2 units in the opposite direction. J prime is 3 units away from the y-axis. So J double prime should be 3 units away. K double prime, J double prime. And L double prime is 5 units away. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So you get kind of a mess, but here's your final shape. So number 2, I have the same, J, K, and L. So let me do that real quick. J, K, L. And this time I have to reflect it across the line y equals x. That's this line right here. This is the line y equals x. I need to reflect the points off that line. So I can either use the rule or I can just count diagonally. Notice how K is 1 diagonal away from y equals x. So K prime should be over here, 1 diagonal on the opposite side. L is 1 diagonal away, so it should be 1 diagonal on the opposite side. So L prime should be where J is currently at right now, and J prime should be currently where L is at, so J prime right there. So here's our result. We could get the same result using the rule. If you're going to reflect over y equals x, the rule is that goes into just yx. So you can see our j prime is at 1, 3, our k prime is at 2, 4, and our L prime is at 3, 1. So if you didn't want to just reflect it across this line, you could use this rule and it'll give you the primes and you can graph it from there. Number 3, same thing, except I'm going to be rotating at 270 degrees this time. So same shape, 3, 1, J, 4, 2, K, 1, 3, L. This time I'm rotating it 270 degrees. And they didn't say, so I should know from that it's going to be counterclockwise. So I need to have some rotational rules handy. So 90 degrees, if I'm rotating 90 degrees, it's negative yx. If I'm rotating 180 degrees, that's negative x, negative y. And if I'm rotating at 270 degrees counterclockwise, it's y, negative x. So j is at 3, 1. If I apply this 270 degree rotation to it, means I take the y value, write it first, and I take the opposite of the x value, write it second. So that becomes negative 3. K currently is at 4, 2. Sorry, this is j prime. K prime would be at, again, take the y value, write it first, 2, take the x value, write it second, and change the sign, negative 4. And L prime, L is currently at 1, 3, L prime would be at 3, negative 1. So let's go ahead and graph those. 1, negative 3 is j prime, K prime is 2, negative 4, and L prime is 3, negative 1. So it's like this shape rotated counterclockwise 270 degrees. Okay. Again in 4, I'm using the same triangle, so 3, 1, 4, 2 is K, 1, 3 is L. But this time I'm applying a scale factor of 2.5, and that's a dilation. It's going to be an enlargement. It's going to be bigger, so I need a shape that's going to be bigger because the scale factor is bigger than 1. So what happens is I just take each one of these points and multiply both x and y by 2.5. So 3 times 2.5 is 7.5. 1 times 2.5 is 2.5 for j prime. K prime, sorry, K, to K prime, 4 times 2.5 is 10. 2 times 2.5 is 5. L, 1, 3, L prime, 1 times 2.5 is 2.5. 3 times 2.5 is 7.5. So then I graph those. So here's 7.5. Here's 2.5. It's j prime. K prime is at 10, 9, 10, and up 5, so somewhere around here. Then L prime is 2.5, and up 7.5. So I can see the shape that I want to have at the end is about 2.5 times larger than my original. Okay, so number 5, this key is reflected across this line, K first, and then that image is reflected across M. The lines intersect at 60 degrees. what transformation could have made this key all the way onto this one? So what single transformation? It would be a rotation. If I just rotated the keys, I could have gotten the same thing. Is it a rigid motion? Yes, rotations are always rigid motions, so are translations and reflections. Rigid motion just means, did you move it, and did the shape stay the same size? This key stayed the same size. So what angle of rotation was this? Well, if this is 60, then I'd kind of double that, because this would be 60, and then this would be 60 to create 120 degrees. And I went this direction, so that's counterclockwise. Alright, so in 6 and 7 we have to do a couple of constructions. The reflection constructions. Across this line I need to reflect this triangle across that line. So my image should end up over here, but it should say roughly the same size. So I'm going to turn my paper sideways like this, so this line looks like it's parallel to me. I'm going to start with A. I put the compass down in A, and I'm going to do an arc, so that intersects the line at 2 spots. So like that. I keep my compass open in that same amount. So from those 2 spots, I make these 2 arcs. And right here, that point is my A prime. After the reflection, let me work on T. Again, compass on T, open it up so that it goes past the line, and I need it to intersect the line twice. So I intersected the line here and here. So go to those spots, make some arcs. That's where T prime would be. C prime. So I'll start at C. Need to open up my compass so it'll intersect the line in 2 different spots. You can always extend the line if you need to. So that's there and there. That's where I intersect the line. Keep my arcs. That's where C prime is at. And I go ahead and connect it, and I'll get the resulting triangle if I reflected it across that line. So you can see this line divides all these lengths in half, so that this would be reflected over there. On 7, I'm supposed to find this image under a 60-degree rotation. So I need to rotate this 60 degrees. So what I like to do in my class is to start with kind of something that looks like the solar system. This is the sun, and these are planets. So I find their orbits by putting my compass at S, opening it up to P, and then here's the path, any rotation around S. If P rotates out around S, it's going to take on that path. If Q is going to rotate around S, it's going to go along this path. And if R is going to rotate around S, it's going to rotate on the outside path, which is really close to the path that I set for Q. So I need to do 60 degrees counterclockwise. So I need to make sure I have all these points go in this direction. So my shape is going to end up over here. I need to know that because I need to anticipate where my shape ends up, because that's how I use my protractor. I'm going to connect S to P. And I use the protractor. If I start like this, I am counting in the counterclockwise direction, so that's the correct way. So S is in the circle, that's P, 10, 20, 30, 40, 50, 60. I'm going to make a dot at 60 degrees. Line that up, but I only want to connect S to the innermost circle, because that's where P prime is. P is only on this revolution. Do the same thing for Q. Connect S to Q. mark out 60 degrees, connect it to the second ring that I created. That's where Q prime is. Same thing for R. Measure out 60 degrees, connect this to the outside. That's R prime. So in the end, what I want to do is I want to connect all these dots that I labeled with primes. Those will recreate my image. And you can see that this is the resultant image if I took this original triangle and rotated it up 60 degrees. 8 and 9 require me to describe some transformations. So on 8, there's no size change, so there's no dilations being involved. So I need to use reflections, rotations, or translations. So I need to go from A, B, C, D to E, F, G, H. It's not, I need to get A to match up with E, B to match up with F, C to match up with G, and D to match up with H. But this isn't in the correct orientation. So what I'm going to start doing first is maybe I should reflect this over so that it faces the same way. So I'm going to decide to reflect it across the y-axis. So the first thing is a reflection across the y-axis. That's the first transformation. That would give me C to be over here, B to be over here, A would be over here, and D would be over here. So now it's going in the same direction, everything's in the same orientation. I just need to have this, all this, land directly on here. So I need to eventually just move this. So I need A to land up on D. Sorry, E. So to do that, I need A to move 1, 2, 3, 4, 5 down, and 1, 2, 3, 4 across to the right. So I need a translation. If I'm just moving to the left and right and up and down, that's a translation. And I need to tell it to move to the right 4 and down 5. That means it's x plus 4, y minus 5. There's a couple different ways to do this one. I think I'll just do the easiest. I need this black shape to land on this gray shape. So before I get there, I would like this black shape to end up here. I need it to end up here. So to do that, I need to move it. Notice how that this is 4, that means each one of these blocks is 2. So I need this point to go here. That means this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I need this to move 9 to the right. So I need a translation. To the right 9 means x plus 9, and then y doesn't do anything, plus 0. Once I have that, I can reflect it across the x-axis, and then I would land directly on my gray shape. So I need to use a reflection across the x-axis.